Hello guys, welcome back to my channel. Today we'll be doing an integral involving the inverse hyperbolic tangent function. So let's get to it. So we have this integral, let's call it I, being equal to, and it's an indefinite integral, so no limit calculations there. So the tang inverse of x over x dx, and the way you pronounce this is tang. So well, before we can do anything, before we can get involved in the complex complexities of integration, let's just review what hyperbolic trigonometric functions are. So say we have a sinh. How is a sinh defined? Well, it's defined as e raised to x minus e raised to minus x over 2. And how's the cosh of x defined? Well, it's the e raised to x plus the e raised to minus x over 2. So naturally our tanh of x is the sinh of x over the cosh of x. This is actually analogous to our circular trigonometric functions. So basically you get e raised to x minus e raised to minus x all over e raised to x plus e raised to negative x. Now when I convert this negative x to a positive x by taking it in the denominator and cross multiplying, I get e raised to 2x, my bad, minus 1 over e raised to 2x plus 1. Well, but the thing is we need to find an inverse of this tanh. So we just find the inverse like we always do for when we the time back in the day when we did in functions, and how to find inverses of functions, whether a function is invertible or not. Basically what you do is you call this thing the entire expression y, and you have to rearrange the terms in such a way so that you get x as the subject of the equation. Okay, so let's go ahead and do that. So let's cross multiply to get y times e raised to 2x plus 1 is equal to e raised to 2x minus 1. Now we can just multiply inside. Y times e raised to 2x plus y is equal to e raised to 2x minus 1. Now we can group some x terms together. So we'll have y times e raised to 2x minus e raised to 2x is equal to 1 minus y. My bad, this is a negative 1 here. Negative 1, negative y. Well, let's factorize the e raised to 2x outside. We have y minus 1 is equal to negative, we can factorize out, y plus 1. And when we just make e raised to 2x as the subject, we have y plus 1 over 1 minus y. Now I can take the natural log on both sides to have ln of e raised to 2x is equal to the natural log of 1 plus y over 1 minus y. That evaluates to nothing but 2x is equal to the natural log of 1 plus y over 1 minus y. Well, now we can legitimately make x as the subject. X equals half of the natural log of 1 plus y over 1 minus y. Now we can just change the variable. We can change x to y and y to x to get y equals half ln of 1 plus x over 1 minus x, and this is what we will call the inverse hyperbolic tangent of x, tanh inverse of x, or arc tanh of x. Yes, that's really a pretty neat way of defining our integral. So finally, because of this um, definition of the inverse tanh, our question I simply becomes indefinite integral of, put the half outside, the natural log of 1 plus x over 1 minus x, but that divided by x outside dx. Let's do this on a separate page. Well, this is our original integral. Now we can actually split it up into two because of this property. So say we have a natural log of b over a, we can write this as the natural log of b minus the natural log of a. That's an intrinsic property of logarithms in general. You can have any base. Here we had e, that's why we call it the natural log. You can have any base in general, and this property, this identity will hold true. So this will totally become integral of ln of 1 plus x over x dx minus half of ln of 1 minus x over x dx. So let's call this I1. Let's call this I2. I'm including the negative sign too. So basically I1 is nothing but half of the integral of ln of 1 plus x all over x dx. And immediately looking at the numerator, the form of the numerator, we might be tempted to use Taylor substitution. So let's go ahead and do that. So half times the integral of the sum from n equals 1 to infinity of negative 1 to the n plus 1th power divided by n times x raised to nth power over this original x dx. So half times, well, we can interchange the integral and the infinite sum, and in real mathematics you actually need to give an elaborate proof of why you can do this. So there are many things that you need to check for. So there's Fubini Tonelli, I think, and then you also have the dominant convergence theorem. Many things, and I think also the monotone convergence theorem. So you also need to check for all of these things, but let's not do that here. It's beyond the scope of this video clearly, and even beyond my scope of knowledge at this point of time. So we have negative 1 to the n plus 1 power over n. Then this is nothing but x raised to n minus 1 dx. Everything else that does not depend on x can be taken outside the integral sign to yield minus 1 to the n plus 1 over n, and the integral x raised to n minus 1 dx. Let's go ahead and simplify the hell out of this thing. N equals 1 to infinity of minus 1 to the n plus 1 over n, and then integrating this using the power rule, we have x raised to n, and over n, the new power, right? Well, this becomes half of the sum from n equals 1 to infinity of minus 1 to the n plus 1th power over n squared and x raised to n. Well, we can actually convert this into our dilogarithm function, but the problem is this alternating part. So the way to do that is to multiply and divide by negative 1 to the nth power. So the way we do that is we take negative x as an argument. The alternating part is as it is. Since so when we do this, this essentially becomes minus 1 to the nth power times x raised to n. So if you notice, compared to our original numerator, we have this negative 1 to the nth power that is extra. So we need to divide that part out to maintain equality. And we also have an n squared in the denominator. So when you use the exponent properties of this thing, we only have a negative 1 to the first power, which is a negative 1, which we can bring out with the half. Then the sum from n equals 1 to infinity of x raised to n, sorry, negative x, the whole thing raised to n because of what we did back there, and n squared. And let's remember that this is nothing but negative half times the dilogarithm of negative x. And the dilogarithm, just for your knowledge, is also called Spence's function. So great, we calculated I1. Time to calculate I2. So I've written down I2 now. And as I said, I'm including the negative sign. It was originally there. So I mean, we can do the same looking at the natural log and the construction of the argument of the natural log. We can definitely use the Taylor series for it. So we have the sum from n equals 1 to infinity of negative 1 to the n plus 1th power divided by n. We also have a negative x this time, as it's being raised to the nth power, all over x. Without worrying much, we can remove the negative 1 to the nth power from this x, negative x, that is, to have x raised to n over x. I'm sorry, I forgot the dx here and the dx here. So now on simplification, now we can totally interchange the sum and the infinite sum and the integral, assuming that our Fubini-Tonelli convergence theorems, they hold true. So we have negative 1 to the n plus 1 power over n, and we also have this n that's being added. So essentially we have a 2n by properties of exponents, and then x raised to n minus 1 dx. Well, this can be split into negative 1 to the 2n times negative 1, right? And now any integer that's multiplied to 2 is going to be even, right? And negative 1 to the eventh power is always 1. So this becomes 1. We are all only left with this negative, which gets multiplied with this negative, making it a positive. And I'm going to pull all the terms that do not depend on x outside. So all we're going to be left with is this 1 over n, and then when we integrate this by the power rule, we'll have x raised to n over n is being multiplied here. So we can go ahead and simplify everything. We have half times the sum from n equals 1 to infinity of x to the n over n squared. And now the best part is this is half of the dilogarithm of x, or you can say the Spence's function. Well, great. We have our I2. Now it's time to plug everything back in. We have I1, we have I2. Let's remember that I was nothing but I1 plus I2. Therefore, I'm going to write the positive part first. So we have I equals half of the dilogarithm of x minus half of the dilogarithm of negative x. And what does that equal, you ask me? It's the indefinite integral of the inverse tanh of x over x dx. Well, interesting result, definitely. And it's going to be useful for us in another video. We can be sure of that. So I hope you enjoyed this video, guys. Please like, share and subscribe, and have a great day.